What if I told you that something out near the orbit of Mars just swelled up into a glowing cloud bigger than entire planets, and almost nobody on Earth noticed? It happened not once, but twice in the same summer, and right now, tonight, scientists around the world are pointing every telescope they have at this object, trying to figure out what it is going to do next. Before we get into it, if you love stories about the strange and real things happening above our heads, take a second to like this video, subscribe to the channel, and share it with someone who still thinks space is boring, because what you're about to hear is anything but boring. The object at the center of this story is a comet, not a rock the size of a city, not some mysterious interstellar visitor, just a comet, a lump of ice and dust that, by all rights, should be one of the most unremarkable objects in the solar system. And yet, in the space of about 10 weeks, it went from being so faint that only robotic survey cameras could even register it, to being visible. From a dark backyard with a cheap pair of binoculars, it brightened by thousands of times in less than a day. Then it calmed down. Then, when everyone thought the show was over, it exploded with light, all over again. This is the story of Comet 229P McNaught. And by the end of this video, you are going to understand not just what happened to it, but why events like this are quietly rewriting what scientists know about the frozen leftovers of our solar system. Let us start at the beginning, because this comet has a real history. It was discovered on May 20th, 2004, by an Australian astronomer named Robert McNaught, working at Siding Spring Observatory. Now, McNaught is not just any astronomer. In the world of comet hunting, he is something of a legend. Over his career, he has discovered dozens of comets, more than almost anyone alive. He did it by patiently sweeping huge sections of the sky with survey telescopes, night after night, looking for tiny moving smudges of light that everyone else missed. And this particular comet, the one we are talking about today, was actually the very first comet to ever carry his name in the official catalog. But here's the thing. When it was found, there was absolutely nothing special about it. It was sitting at around magnitude 17. To give you a sense of what that means, the faintest stars you can see with your naked eye on a perfectly dark night are about magnitude 6. A magnitude 17 object is thousands of times fainter than that. You could aim a decent amateur telescope right at it and see nothing. It took serious equipment and long camera exposures just to prove it existed. Comet 229P belongs to a group called the Jupiter family comets. These are comets whose orbits have been grabbed and reshaped by Jupiter's gravity over millions of years. Unlike the famous long-period comets that dive in from the edge of the solar system once every few thousand years, Jupiter family comets stick around. They loop around the sun on relatively short cycles, over and over again. For 229P, one full trip around the sun takes about 5.5 years. Its closest approach to the sun, which astronomers call perihelion, brings it to about 1.6 astronomical units out. That is just a bit beyond the orbit of Mars. Then it swings back out toward Jupiter's neighborhood, turns around, and does the whole thing again. Its entire existence is a slow, endless shuttle run between the inner solar system and the cold outer dark. And for over 20 years, that is all it ever did. Every orbit, the same routine. It would brighten slightly as it approached the sun, fade as it moved away, and absolutely nothing interesting would happen. Astronomers logged it, filed it, and mostly forgot about it. It was, to be blunt, a boring comet. Until this year. In late May of 2026, something changed. The Zwicky Transient Facility, a robotic survey in California that photographs the entire visible sky every single night, picked up something odd. An astronomer named Mike Kelly was the first to flag it. Comet 229P, the quiet, predictable, boring comet, had suddenly jumped in brightness by about 7 magnitudes. 7 magnitudes. In plain language, that is roughly a 600-fold increase in brightness, and it happened in a window of about 13 to 14 hours. Think about that for a second. Imagine you're sitting in a dark room with a single candle burning in the corner. You blink, and when you open your eyes, the candle has turned into a stadium floodlight. That is the scale of what this comet did, in less time than it takes to get a full night's sleep. And it did not stop there. Observers who tracked it over the following nights watched it climb even higher, eventually reaching about magnitude 8.2. Compared to its normal resting state, the comet had become roughly 8,000 times brighter. 8,000. An object that had spent 2 decades as an invisible smudge was suddenly within reach of ordinary binoculars. What happened here has a name. It is called a cometary outburst, and it is one of the most violent things a comet can do without actually dying. Here's how it works. The heart of every comet is its nucleus, a solid core of ice, rock, and frozen gases. When a comet approaches the sun, sunlight heats the surface, but buried beneath, that crust are pockets of exotic ices, things like frozen carbon dioxide and frozen carbon monoxide, which turn straight into gas at much lower temperatures than water ice. These pockets are under pressure. They are sealed in. And as the heat builds, something has to give. Sometimes the crust cracks from thermal stress. Sometimes a small landslide on the surface tears open a weak spot. Sometimes a chunk of the nucleus simply breaks off. Whatever the trigger, the result is the same, the trap tube. Gas finds an exit, and it erupts outward all at once, dragging an enormous cloud of dust with it. And from Earth, we see that eruption as a sudden, dramatic flare of light, because now there's a huge cloud of fine particles reflecting sunlight instead of just one tiny solid core. Now, if you are finding this as fascinating as I do, this is the perfect moment to hit that subscribe button, because we cover space stories like this every week. And trust me, you do not want to miss what is coming next. Drop a like if you have ever looked up at the night sky and wondered what else is out there that nobody's talking about. Here's where the story gets even more interesting. Right around the time of the first outburst, professional astronomers swung the TRAPPIST-North telescope in Morocco toward the comet to study its chemistry, while it was still hot, so to speak. And what they found raised some eyebrows. The coma, which is the cloud of gas and dust surrounding the nucleus, was loaded with an unusual amount of a molecule called diatomic carbon, or C2, especially compared to cyanogen, another gas that comets commonly release. That imbalance told scientists something about the comet's internal recipe, about what kind of primordial material it had been storing since before the planets existed. The C2 molecule also explained something that astrophotographers have been capturing beautifully. If you look at recent images of this comet, you will notice the coma has a distinct greenish glow. That green is not a camera trick. It is not editing. When sunlight strikes diatomic carbon molecules floating in space, they absorb the energy and re-emit it at very specific wavelengths. And those wavelengths fall right in the green part of the spectrum. So when you see that eerie emerald core in the photos, you are literally looking at the comet's chemistry made visible. You are seeing its ingredients glowing. The astronomers also spotted something else in those images. A narrow, intense dust tail, sharp and well-defined. And that detail, combined with the violence of the outburst, led them to float a more dramatic possibility. Maybe this was not just a crack venting gas. Maybe the nucleus had actually broken apart, at least a little. Scientists call this a fragmentation event, and it is a big deal because when a piece of the nucleus splits away, it exposes ice that has never in 4.5 billion years been touched by sunlight. Fresh, pristine, deeply frozen material, suddenly flash-heated. That kind of exposure can vaporize explosively, and it can keep a comet active long after a normal outburst would have fizzled out. On June 14th, 2026, the comet reached perihelion, its closest point to the Sun, at that distance of about 1.6 astronomical units. And this timing matters, because perihelion is when a comet is under maximum thermal stress. If an outburst is going to happen, this is usually when. But here's the strange part. By the time 229P actually reached its closest approach, the show was already winding down. Observers had noticed in early June that its dust production had dropped sharply from one night to the next. By June 8th, it had faded to around magnitude 11, still far brighter than its old self, but clearly settling down. Astrophotographers captured it during this cooling-off period, and the images told the story visually. The once-round coma had stretched into a soft teardrop shape, its center becoming elongated and diffuse. The eruption was over. The material was spreading out, thinning, dissolving back into the black. By early August, the comet had dimmed to about magnitude 13. Everyone assumed the excitement had passed. The comet had done its dramatic thing, the data had been collected, and now it would quietly finish its pass by the Sun and head back out into the cold, same as always. Then came August 5th. Without any warning whatsoever, Comet 229P lit up a second time. It jumped all the way back to around magnitude 7, which means the second outburst may actually have been brighter than the first. The amateur astronomy community was stunned all over again. And this is the part of the story that turns a cool event into a genuinely rare one. A single major outburst during one pass by the Sun is already unusual. Two major outbursts in the same apparition, separated by only about 2 months, is something comet scientists see very, very rarely. And that is why, right now, this faint little patch of light has the attention of observers on every continent. Because nobody knows if there is a third act coming. Now let us talk about the title of this video, because it is not clickbait. When people hear that this comet has grown to something larger than Jupiter, the natural reaction is disbelief. How can a ball of ice barely bigger than a small town become larger than the biggest planet in our solar system? The answer lies in understanding the difference between the nucleus and the coma. The solid nucleus of a comet like 229P is tiny. Based on studies of similar Jupiter family comets, it is probably only 1 to 2 kilometers across. You could walk around it in an afternoon. But the coma is a different beast entirely. Once the comet starts venting, the gas and dust it releases face no air resistance. There's nothing in the vacuum of space to hold the cloud in or slow it down, so it expands and expands and expands, pushed outward by the pressure of the eruption and the constant stream of sunlight. The solid body stays small, but the glowing envelope around it can balloon to truly absurd sizes. And if that sounds like an exaggeration, history has a receipt. In October of 2007, a comet called 17P Holmes pulled off the most dramatic outburst ever recorded. It brightened by a factor of about 1 million in a matter of days, leaping from magnitude 17 to magnitude 2.8, bright enough to see with the naked eye even from inside a city. But the truly mind-bending part came afterward. The cloud of gas and dust it released kept growing week after week, until at its peak, the coma of Comet Holmes was physically wider than the sun itself. The sun, produced by a nucleus only a few kilometers wide. It remains one of the most astonishing events in modern astronomy, and it is the ultimate proof that a small, frozen, forgettable object can, for a brief window of time, wear a cloak of light bigger than worlds. That is the historical lens through which scientists are viewing 229P right now. Even during the first outburst back in June, observers measured a coma spanning several arc minutes across the sky and reported a faint ion tail stretching more than 2 full degrees long. 2 degrees might not sound like much, but the full moon is only half a degree wide. This comet's tail of charged gas, blown back by the solar wind, stretched across a patch of sky 4 times wider than the moon. As for exactly how big the coma has grown during this second August eruption, those measurements are still coming in as new images arrive night by night. But the pattern already matches the profile of a comet capable of producing a cloud that dwarfs the small body buried at its center. If you're getting value out of this deep dive, do me a quick favor and share this video with just one friend who loves space, and tap subscribe so the algorithm knows to keep bringing you stories like this one. We are just getting to the good part. So where's the comet right now? And more importantly, can you actually see it with your own eyes? As of this week, 229P is sitting in the constellation Cetus, the whale, which currently lives in the pre-dawn sky. For those of you in the northern hemisphere, the timing is a little awkward. A half-lit moon is rising around the same time as the comet, and moonlight is brutal on faint, fuzzy objects. A comet's coma does not have the sharp, concentrated brightness of a star. It is a soft smudge, and soft smudges get washed out easily. Southern Hemisphere observers have it slightly better at the moment, with a roughly 30-minute window of moonless darkness before dawn, though even then the comet hangs low over the eastern horizon, so you need a clear, unobstructed view. If you want to try, the advice from veteran comet watchers is simple and time-tested. Get away from city lights. Seriously, drive out somewhere dark. Give your eyes a full 15 to 20 minutes to adapt to the darkness, because your night vision builds slowly. Bring binoculars if you have them. Counterintuitively, a faint fuzzy glow is often easier to spot through binoculars than with the naked eye because they gather more light and concentrate the view. A small telescope is even better and might reveal structure inside the coma or a hint of the tail. And here is the most important piece of advice of all. Do not wait. Comets and outbursts are wildly unpredictable. They can fade as fast as they flare. If you have a clear night, take it, because there is zero guarantee it will still be this bright next week, or even in a few days. Now, at this point, a fair question might be forming in your mind. Why should anyone care this much about a tiny, faraway comet? It is not going to hit us. It is not going to affect our lives in any direct way. So why are professional observatories and backyard astronomers alike dropping everything to watch it? Here is a detail that rarely makes it into the headlines, and it is one of my favorites. The nucleus of a comet is one of the darkest objects known to science. You might picture it as a shining white snowball, but the reality is closer to a lump of charcoal. The surface of a typical comet nucleus reflects only about 3 to 5% of the light that hits it, which makes it darker than fresh asphalt, darker than coal. We know this from spacecraft that have visited comets up close, and the reason is that the ice is mixed through with ancient carbon-rich organic compounds, a black terry residue that coats everything. So when you see that brilliant, glowing coma in a photograph, remember this. All of that light is coming from a cloud of escaping gas and dust illuminated by the sun. The object at the center is a blackened, crusted lump you could barely see even if you were standing right next to it. The comet's glory is entirely its own exhaust. The answer is that comets are time capsules. Genuine 4.5 billion-year-old time capsules. When our solar system was forming, before the Earth had even finished assembling itself, The outer reaches of the disk of gas and dust around the young sun were cold enough for ices to form and survive. Comets are the leftover construction material from that era. They are chunks of the original recipe, the raw ingredients of planets that never got used. And for billions of years, they have been drifting in. Deep freeze, almost completely unchanged, holding that ancient chemistry in suspension. Every time a comet like 229P swings close to the sun and erupts, it releases material that has literally not been touched since before the Earth existed. When the Trappist astronomers detected that unusual richness of diatomic carbon in June, they were not just measuring a gas. They were sampling the primordial soup of the solar system, delivered to our telescopes free of charge without having to launch a single spacecraft. Every outburst is a sample return mission that nature runs for us. Jupiter family comets are especially valuable for this kind of science, and the reason is repetition. A long-period comet might visit the inner solar system once every 10,000 years. You get one shot at studying it, and then it is gone beyond the reach of any telescope. But a Jupiter family comet comes back every few years, again and again. Scientists can watch the same object age. They can compare one apparition to the next. They can observe how a comet degrades, how it changes, how it slowly spends its frozen reserves. Some of these comets eventually run out of accessible surface ice and go dormant, becoming so quiet they are almost indistinguishable from ordinary asteroids. Others, for reasons nobody fully understands, keep erupting with drama even after dozens of orbits. Which path will 229P take? Will it settle back into its old boring routine after this year? Or has something inside it changed permanently? Only continued observation will tell. And 229P is not performing alone this season, by the way. The summer of 2026 has been unusually busy for comet watchers. Comet 10P Tempel 2, another periodic comet on a similar 5.5-year orbit, passed its own perihelion on August 2nd, coming within about 1.4 astronomical units of the Sun, putting it in roughly the same celestial neighborhood as 229P at roughly the same time. Comet 88P Howell, also on a 5.5-year cycle, reached perihelion back in March at a comparable distance. For people who track these objects, it has felt less like a quiet season and more like a festival. Let me also address the question that always comes up whenever an object in space makes headlines. Is there any danger? Should we be worried about this thing? The answer is a clear and simple no. Comet 229P spends this entire part of its journey out near the orbit of Mars. Even at its closest to the Sun, it is more than 1.5 astronomical units out, which keeps it tens of millions of kilometers away from Earth at all times. Its orbit does not cross ours. There's no collision scenario, no near-miss drama, nothing. And that is actually one of the elegant things about periodic comets. Because astronomers have tracked them across multiple orbits, their paths become exquisitely predictable, decades into the future. What happens on the comet is a mystery. Where the comet is going is not. All of the excitement here is about light and chemistry and distance, not risk. This is pure science, pure spectacle, zero threat. We are going to keep following this comet as the story develops, so if you have not already, now is the time to subscribe and ring the notification bell, because if this object flares up a third time, you will want to hear about it here first. Let us zoom out for a moment and put this event in its proper context, because understanding how 229P compares to other comets is the key to understanding why astronomers are so fired up. We already talked about Comet Holmes and its millionfold brightening in 2007, which stands as the extreme benchmark. But at the other end of the scale, there's a comet called 29P Schwarzmann-Wachmann, which is famous among comet enthusiasts as the most frequently U. Erupting comet, we know. It outbursts regularly, sometimes several times a year, but its eruptions are modest, typically between 1 and 4 magnitudes. A hiccup, not an explosion. Now compare that to what 229P has done. Its first jump was about 8,000 times its baseline brightness, achieved in roughly half a day. That alone would have made it one of the most notable comet events of the decade. But then, it did it again. And this repeat performance is the part that has scientists genuinely puzzled, because the mechanics of back-to-back major outbursts are not well understood at all. There are a few competing ideas. One theory says that once a nucleus suffers its first major fracture, the damage does not heal. The exposed crater left behind by the first outburst remains unstable, riddled with fresh cracks and newly exposed ice, and as the sun continues to bake the surface, that wounded region becomes prone to secondary collapses and secondary eruptions. In this view, the second outburst is essentially an aftershock of the first. Another theory is stranger. It suggests that the nucleus of 229P might not be one solid body at all. It might be a loose cluster of 2 or more pieces, gently bound together by gravity, what scientists sometimes call a contact binary or a rubble pile structure. Astronomers have documented this arrangement in a handful of other comets, and if that is the case here, then each piece could vent independently on its own schedule, triggered by its own internal pockets of gas. 2 outbursts, 2 different pieces of the same broken heart, each waking up as the heat reaches it. At this stage, with the second outburst only days old, researchers are still collecting images and spectra, still comparing brightness curves, still arguing. A definitive answer might take months, it might never come at all. And that is worth saying out loud because it is easy to forget. Comets, even after centuries of observation and multiple spacecraft missions, remain genuinely unpredictable. They are one of the last places in solar system science where surprise is still routine. There is also a human thread running through this story that I find quietly moving. Think about Robert McNaught, the man who found this comet back in 2004. He spent his career doing one of the most patient jobs in science, scanning the sky night after night, year after year, collecting faint smudges that most people would never think about twice. When he logged this particular smudge, it was magnitude 17, invisible to anything but his survey telescope, one discovery among dozens. He could not have known that more than 20 years later, this unassuming little object would erupt into one of the most watched comets on the planet, that his first namesake comet would, 2 decades after its discovery, suddenly decide to put on the show of its life. There is something poetic about that, the patient work of one man and the patient drift of one comet, finally colliding in a moment of light. There's also a deep history folded into this moment because human beings have been watching comets with alarm and wonder for as long as we have been writing things down. Ancient Chinese astronomers kept meticulous records of what they called broom stars, going back more than 2,000 years, cataloging their shapes, their directions, their colors. Babylonian scribes pressed comet sightings into clay tablets. In medieval Europe, comets were treated as omens of plague, war, and the death of kings. When Halley's Comet appeared in 1066, it was stitched into the Bayeux tapestry as a harbinger of the Norman conquest, with crowds of onlookers pointing at it in terror. For most of human history, a bright comet was not a curiosity. It was a message, and the message was usually frightening. What changed everything was science learning to predict them. When Edmund Halley used new mathematics to show that the comet of 1682 was the same object as the comets of 1531 and 1607, and that it would return in 1758, he did something revolutionary. He took one of the sky's greatest terrors and turned it into an appointment. The comet returned on schedule, 16 years after Halley's death, and overnight, comets stopped being omens and started being citizens of the solar system, regular, lawful, trackable. Every comet we study today, including 229P, is a descendant of that shift in human thinking. We no longer ask what a comet means. We ask what it is made of, where it has been, and what it can teach us. That might be one of the quietest and greatest victories in the history of thought. And honestly, I think there is something worth sitting with here beyond the science. Consider what actually happened this summer. A piece of ice and rock about the size of a small hill, which had been drifting in silence and darkness for billions of years, woke up. Twice. It threw off enough ancient frozen material to build a glowing cloud visible from every inhabited continent on Earth. It transformed itself from an object that only robotic cameras could perceive into something a kid with $10 binoculars could find in a dark backyard. Nobody commanded it. Nobody predicted it. Heat, ice, pressure, and time conspired millions of kilometers away, and the result was light. You do not need to dress that up in mythology or mystery. The plain physics of it is already as close to magic as the real world gets. Every time a comet flares like this, it opens a small temporary window. For a few weeks, the chemistry of the early solar system, sealed away since before Earth finished forming, gets sprayed out into the sunlight where our instruments can taste it. Then the window closes, the cloud thins, the gas disperses, and the comet returns to the dark, carrying whatever secrets it still has left. The material glowing in 229P's coma tonight has been frozen since before there were oceans, before there were continents, before there was anything on Earth that could look up. And for just a moment, it is shining. To really appreciate what is happening with 229P, it helps to understand what is going on inside its tail, because a comet actually wears 2 of them, and they are not the same thing at all. The first is the dust tail. This is the broad, curved, yellowish-white fan you see in most comet photographs. It is made of tiny solid grains, silicate particles, and carbon-rich specks, blown off the nucleus by the escaping gas. These grains do not glow on their own. They shine purely by reflecting sunlight, the same way dust motes in a sunbeam do. Because the grains are heavier than gas molecules, the sun's radiation pressure pushes them gently rather than violently, and they lag behind the comet along its orbit, which is why the dust tail always has that graceful, curved shape, like smoke trailing from a moving train. The second tail is the ion tail, and this one is a different animal entirely. It is made of gas that has been ionized, stripped of electrons by ultraviolet sunlight, and once those molecules carry an electric charge, they become prisoners of the solar wind, the constant stream of charged particles blasting outward from the sun at hundreds of kilometers per second. The solar wind grabs those charged molecules and hurls them straight away from the sun in a line so direct it looks drawn with a ruler. The ion tail glows on its own, fluorescing in blues and greens as its molecules re-emit energy. And here is the detail I love most. Both tails always point away from the sun. Always. Which means that when a comet finishes perihelion and heads back out into deep space, it travels tail first. The tail streams out in front of it like a flag on a car antenna. Comets are the only things in nature that fly their banners ahead of them. The ion tail reported on 229P in June, stretching more than 2 degrees, 4 full moon widths, was not just decoration. Its length was data. A tail that long tells scientists that gas was pouring off the nucleus at an enormous rate, because tails fade fast. The material streaming away disperses into the void within days. To sustain a tail of that scale, the comet had to be continuously replenishing it, hour after hour, like a fountain that never rests. There is one more twist to the tale. Story that deserves a mention because it is one of the strangest phenomena in all of comet science. Every so often, as Earth passes through the plane of a comet's orbit, geometry plays a trick on us. For a night or two, we see the tail from directly edge on, and the foreshortening creates the illusion of a second spike of light pointing toward the sun instead of away from it. It is called an anti-tail, and for centuries it baffled observers who thought comets were somehow growing horns. It is pure perspective, nothing more, but it is a reminder that even trained eyes can be fooled and that half the work of astronomy is learning to distrust what seems obvious. That is also why the global response to this event matters. Right now, a kind of informal planetary scale collaboration is underway. Professional observatories running dedicated comet monitoring programs are sharing data with amateur astronomers who are imaging the comet from their driveways. Brightness estimates are being posted and compared almost daily. Astrophotographers are stacking exposures to reveal structures in the tail that no single image could show. This is how comet science actually moves when something surprises us. Not through one big institution, but through hundreds of people on every continent, all looking at the same small patch of sky and comparing notes, events. Like the twin outbursts of 229P get understood precisely because of that collective attention. So what happens next? The honest answer is that nobody knows. The comet is now beginning its long retreat from the sun, heading back out toward the far end of its orbit, where it will spend the next few years cooling down in the dark. If it follows the normal script, it will fade week by week until it slips back below the threshold of our telescopes and resumes its quiet life. But 229P has already torn up the normal script twice this year. A nucleus that has cracked open once or twice may have more instabilities left in it. More pockets of ancient gas waiting for their moment. The observers tracking it tonight are not just watching a fading light. They are waiting with real anticipation to see if a quiet little traveler from the edge of the asteroid belt has one more eruption left in it before it goes. If this story earned your curiosity, the best thing you can do is pass it on. Send this video to someone who needs a reminder that the universe is still full of surprises, like the video if you made it this far, and subscribe if you want to be here for whatever this comet does next, because we will be covering it. If you take away only one thing from this video, let it be this. Tonight, or some clear night soon, if you can get somewhere dark, go outside. Look toward the pre-dawn sky near the constellation Cetus with binoculars if you have them. You might catch it, you might not. The moon might interfere, the comet might have faded, the clouds might win. But if you do find that faint green smudge hanging over the horizon, take a moment with it. Because you will not be looking at just a smudge. You will be looking at a survivor from the birth of everything you know, a fragment of the original cloud that became the sun, the planets, and eventually you. Material that waited 4.5 billion years in the cold and the dark and chose this summer, our summer, to finally step into the light. A comet, smaller than a town, made a cloud larger than worlds. It did it twice, and it might do it again. And the only way to know is the same way humans have always known. Look up. Keep looking up. Because somewhere out there, right now, the next surprise is already on its way, 5.5 years at a time. See,